So for the first question, the vapor pressure of pure water at 115 degrees Celsius is 1085 torr. A solution of ethylene glycol and water has a vapor pressure of 1.30 atm at the same temperature. What is the mole fraction of ethylene glycol in the solution? So first of all, we list all the given. So yung vapor pressure of the pure solvent, which is yung pure solvent dito is yung water. Yung symbol niya is yung P raised to O H2O. And dito sa problem, ang given niya is 1085 torr. Then next given is yung P sub A, or ito yung partial pressure of the solvent vapor above the solution. So sa formula, ayun yung P solution. So dito sa problem, ayun yung 1.30 atm. Then since naka atm siya, we should convert it into torr. And the conversion factor is 1 atm is equals to 760 torr. So, ang gagawin natin is si 1.30 atm ita times natin siya sa conversion factor na 760 torr over 1 atm. So, cancel natin si atm and multiply natin si 1.30 sa 760 and kakalabasan is 988 torr. So 1.30 atm is equals to 980 torr. And yung 980 torr ay yun yung gagamitin natin sa solution. So, doon tayo sa formula. Yung formula is P sub A is equals to X sub A times P raised to O sub A. So dito, si P sub A ay si P solution is equals to ang X sub A natin is si X H2O. And then si P raised to A sub A ay si P raised to O H2O. So, ano nga ba yung itong mga to? Si P solution is si 988 torr. Kung saan ito yung partial pressure ng solution. And then, si XH2O, siya si mole fraction ng solvent. And then, si P raised to O, H2O, siya yung vapor pressure ng pure solvent. Then, since ang hinahanap ay mole fraction ng ethylene glycol, which is ang ethylene glycol ay solute, ang hanapin muna natin is si mole fraction ng solvent, which is si water. So, divide both sides by P raised to O, H2O para makancel siya dito. Kaya ang magiging formula na natin para mahanap si XH2O ay P sol N over P raised to O, H2O is equals to XH2O. And then, para mahanap naman si mole fraction ng ethylene glycol, which is ang solute natin, ay isusubtract natin si mole fraction ng solvent, which is si water, sa 1, since alam naman natin na mole fraction ng solute at ng solvent kapag pinag-add is equals to 1. Kaya ang formula para mahanap si mole fraction ng ethylene glycol ay X sub Eg is equals to 1 minus X sub H2O. So, sa solution naman, nadali lang. plug in all the values, 988 torr over 1085 torr, cancel si torr, matitira ay 0.91. And si 0.91, siya yung mole fraction ng solvent, which is ng water. And then para mahanap si mole fraction ng ethylene glycol, is susubtract natin si 0.91 sa 1. Kaya ang kakalabasan, ang mole fraction ng ethylene glycol sa solution ay 0.09. So for the second question, what is the molality of a solution dissolved in chloroform that boils at 62.8 degrees Celsius? Boiling point of chloroform is 62.2 degrees Celsius, and Kb of chloroforms is 3.63 degrees Celsius over m. So, nakuha si Kb dito sa table na to, which is, titingnan natin yung molar boiling point elevation constant. So, ayun yung Kb. And, tingnan natin si chloroform. Ito. And 3.63 degrees Celsius over m or mole. So, yun. Then, ang una natin gawin is given. Ang temperature natin ay may dalawa, 62.8 degrees Celsius and 62.2 degrees Celsius. And then yung Kb natin or yung molar boiling point elevation constant ay 3.63 degrees Celsius over mole. Then, ang kailangan nating hanapin is molality of a solution or yung molality ng solution. Then, di ba may formula tayo ng boiling point elevation, which is boiling point elevation is equals to molar boiling point elevation constant multiply to molality of solution. Since molality of solution ang hinahanap, i-derive natin siya, ito, by dividing both sides by Kb para mahanap si m. Then, para mahanap naman si boiling point elevation, since given tayo ng dalawang temperature, yung temperature ng chloroform or yung boiling point ng chloroform at nung nagboil siya kasama yung solvent or yung temperature ng buong solution, which is 62.8 degrees Celsius at 62.2 degrees Celsius. Then, ayun, plug in yung dalawang temperature para mahanap si boiling point elevation, which is 62.8 degrees Celsius minus 62.2 degrees Celsius is equals to 0.6 degrees Celsius. Ito yung boiling point elevation. And then, doon naman sa second na formula, i-divide si boiling point elevation, which is 0.6 degrees Celsius sa Kb or yung molar boiling point elevation constant, which is 3.63 degrees Celsius over molar. Then, divide both sides by our cancel yung degrees Celsius, matitira. And then, i-divide natin na siya, magiging 0.17. And yung unit for molality is m, small letter m. And then, yun, ang molality ng solution ay 0.17 m.
So for our problem, we are asked to calculate the vapor pressure lowering dP when 10 ml of glycerol C3H8O3 is added to 500 ml of water at 50 degrees Celsius. At this temperature, the vapor pressure of pure water is 92.5 torr and its density is 0.988 gram per milliliter. And yung density naman ng glycerol is 1.26 gram per milliliter. So, para lang mas malinawan tayo dun sa given ng problem, so sinulat ko siya. So, we are given the volume of glycerol and water. So, sa glycerol, we have 10 ml and sa water, we have 500 ml. So, kung makikita natin dito, mas malaki yung amount ng water, which is 500 ml. So, siya yung solvent. Next is also, we are given the temperature of water, which is 50 degrees Celsius, and the vapor pressure of water, which is 92.5 torr. Also, the density of water and glycerol. So water, 0.988 gram per milliliter, and sa glycerol, we have 1.26 gram per milliliter. Also, I have written here the molar masses of water and glycerol. So sa glycerol, we have 92 gram per mole, and sa water, we have 18.02 gram per mole. So, gagamitin natin siya sa conversion part mamaya sa solution. So, next. So, ito na, yung solution. So, first, we're going to convert the volume of water to moles. So, how can we do that? First, we are to multiply the volume of glycerol to its density. So, 10 ml of C3H8O3 multiplied by its density, which is 1.26 gram per ml, para ma-cancel ko. So, multiplied by 1 mole divided by its molar mass, which is 92.10 gram per mole. And we will going to get 0.137 mole of glycerol. Next is sa water naman. So, we have 500 ml of water multiplied by its density, which is 0.988 gram per milliliter, multiplied by 1 mole divided by its molar mass, which is 18.02 gram per mole, and we will going to get 27.414 mole of water. So, next step is kukunin natin yung mole fraction. In this problem, ang ating solvent is water, kaya siya ang ating numerator. So, yan. Ito ang ating nagamit formula. So, moles of water, which is 27.414, and i-add lang natin yung mole ng water and ng glycerol, and we will going to get 27.551 mole. I-divide natin siya, and we will going to get 0.995, which is our mole fraction. So, dahil ang hinahanap nga natin is vapor pressure, we will going to apply the Raoult's law, which is a formula of mole fraction of solvent multiplied by the pressure of solvent. So, ang nakuha natin kanina is 0.995, and ang ating given na vapor pressure is 92.5. So, multiply lang natin siya, and then we will get 92.0384 or 92.04, which is logical siya maging vapor pressure lowering dito dahil mas mababa siya sa 92.5. So, that's it. For our second problem, we are given a scenario that if you add 1 kilogram of ethylene glycol antifreeze C2H6O2 to your car radiator, which contains 4,450 grams of water, what are the boiling and freezing points of the resulting solutions? So, in this problem, we are given a 1 kilogram of ethylene glycol C2H6O2 and 4,450 grams of water, and we are to find the boiling point and freezing point. So here we have a conversion of grams to kilograms because we need the molality. So kapag hahanapin ang boiling point and freezing point, molality yung kailangan. So with that, the formality is mole of solute divided by kilogram of solvent. So here we have 4,450 grams divided by 1,000 grams. We will get 4.45 kilograms. And also here is the molar mass of the ethylene glycol, which is 62.068 gram per mole. So here is the solution. So first, convert muna natin yung 1 kg of ethylene glycol sa grams. So, para ma-cancel to. So, we have 1,000 grams of ethylene glycol divided by its molar mass, which is 62.068 gram per mole. We will going to get 16.111 moles of ethylene glycol. So, now that we have the moles of solute, which is 16.111 moles, so, i-divide naman natin siya dun sa 4.45 kilograms of nung solvent. So, we will get 3.62 na molality. So, now, we will get the boiling point and the freezing point. So, first, boiling point muna. So in this problem, our solvent is the water, which has a boiling point of 100 degrees Celsius, plus yung boiling point elevation, ito yung dP. So, with that, ang formula natin sa boiling point elevation is boiling point constant multiplied by molality. So, dahil ang constant ng water natin, boiling point constant ng water natin is 0.512 multiplied by 3.62, which is our molality. Ang makukuha natin is 1.85. And dahil ang boiling point ng water is 100, i-add lang natin yung 100. Na makakuha tayo ng 101.85 degrees Celsius as our boiling point. Next is the freezing point. So the freezing point of water, our solvent here in the problem, is 0 degrees Celsius. So minus Tf, which is the freezing point depression. So with a formula of Kf, which is the freezing point depression constant multiplied the molality. So here we have a 1.86. That's the constant freezing point constant of water, depression of water, multiplied by 3.62, which is our molality, and we will going to get 6.73 degrees Celsius. So i-minus lang natin yun sa 0. So 0 minus 6.73, we will going to get negative 6.73 degrees Celsius as our freezing point.
For problem number 3, the boiling point of an aqueous solution is 102.5 degrees Celsius. What is the freezing point of the solution? Given the boiling point of the solution 102.5 degrees Celsius and Kb is equal to 0.512 degrees Celsius over m and Kf is equal to 1.86 degrees Celsius over m. So for the solution, in order to determine the change in boiling temperature of water, we need to subtract the boiling point of water solution from the boiling point of solvent, and that is 102.5 degrees Celsius minus 100 degrees Celsius, and that is equal to 2.5 degrees Celsius. To find the molality of the solution, we need to use the equation delta Tb is equal to Kb times m. So that is, molality is equal to delta Tb over Kb. So direct substitution for the values, that is 2.5 degrees Celsius over 0.512 degrees Celsius over m, and that is equal to 4.88 m, or 4.88 molality. So next is, to find the freezing point of the solution, we need to use the equation delta Tf is equal to Kf times m. Direct substitution from the values 1.86 degrees Celsius over m times 4.88 m, and that is equal to 9.08 degrees Celsius. So to find the freezing point, we need to subtract the normal freezing point to the change in the first temperature. So that is 0 degrees Celsius minus 9.08 degrees Celsius, and that is equal to negative 9.08 degrees Celsius. For problem number 4, a solution of propylene glycol or the antifreeze in the car's radiator has a freezing point of negative 20 degrees Celsius. What is the molarity of the solution? Given the freezing point, and that is equal to negative 20 degrees Celsius, the freezing point of water is 0 degrees Celsius, and Kf is equal to 1.86 degrees Celsius over m. For the solution, to find the change in the first temperature, we need to subtract the normal freezing point to the freezing point of the solution, and that is 0 degrees Celsius minus negative 20 degrees Celsius, and that results to 20 degrees Celsius. So to find the molality of the solution, we need to use the equation delta Tf is equal to Kf times m. So molality is equal to delta Tf over Kf. Direct substitution for the given values, that is 20 degrees Celsius over 1.86 degrees Celsius over m, and that results to 10.8 molality.
Third question is, a solution prepared from 0.3 grams of an unknown non-volatile solute and 30 grams of CCl4 has a boiling point of 0.392 degrees Celsius. higher than that pure CCl4. What is the molecular weight of the solute? The boiling point constant is 5.02 degrees Celsius per molality, and the solute is equals to 0.3 grams and solvent with 30 grams. The boiling point is 0.392 degrees Celsius. Then the equation is boiling point constant is equals to molal boiling point elevation constant times the molality of solution. Then we're going to perform the equation. 0.392 is equals to 5.02 multiplied by 0.3 times 1000 all over 30. Then we're going to have 0.392 is equals to 50.19 over x, and we're going to divide 50.019 by 0.392, and we're going to get 128.06 grams is the molecular weight of the solute.
Fourth question is calculate the boiling point of an aqueous solution that contains 20% ethylene glycol, which is a non-volatile liquid. First is grams to molal concentration, or per 1000 grams of solution. Ethylene glycol is 200 grams, water with 800 grams, and the equation is molality is equals to mol H2H6O2 over kilograms of H2O. Then we're going to perform the equation. 200 grams of C2H6O2 over 800 grams of H2O multiplied by 1 mole of C2H6O2 over 62.07 grams of C2H6O2, and then multiply by 1000 grams of H2O over 1 kilogram of H2O, and we get 4.03. That will be the molality of the solute. Then second is calculate boiling point and freezing point change. The freezing point constant of water is 1.86 degrees per molality, and the boiling point constant is 0.52 degrees per molality. Then the boiling point elevation is 0.52 degrees of per molality of times 4.03 molality. We will get 2.1 degrees Celsius. Then for the freezing point elevation, 1.86 times 4.03, we will get 0.5 degrees Celsius. Then for the normal boiling point of water is 100 degrees, and for the normal freezing point is 0 degrees Celsius. Then to calculate the boiling point, we're going to add 100 degrees Celsius plus the answer that we get from the freezing point elevation, or from the boiling point elevation, which is 2.1 degrees Celsius, that we will have 102.1 degrees Celsius, and for the freezing point is 0 degrees Celsius, and add the answer that we get from the freezing point elevation, which is negative 7.5 degrees Celsius. We're going to have negative 7.5 degrees Celsius for the freezing point.